Our world is just humming with these invisible forces. We're practically swimming in them, using them all the time, but we can't see any of it. And these unseen powers, they're the secret behind some of the most mind-boggling and frankly brilliant technologies we use every single day. I mean, just think about it for a second. How can we cook food in a box without any fire? You take something raw, pop it into a metal container, hit a button, and boom, a few minutes later, it's steaming hot. There's no fire, no glowing red-hot element. So what in the world is actually doing the cooking? Or what about this? How can we see our own bones without ever breaking the skin? I mean, doctors can literally peer right through our skin, our muscles, and see the solid bone structure underneath, all from a single image. It's like having X-ray vision straight out of a comic book. How on earth is that even possible? And here's maybe the most common miracle we take for granted every day. How can we talk to someone across the planet? Instantly. You speak into this little device in your hand, and your voice is heard in real time by someone on the complete opposite side of the globe. What invisible messenger is carrying your voice across oceans and continents in just the blink of an eye?
So, we've got cooking without fire, seeing through our own bodies, and talking across the planet. You'd think these things have absolutely nothing in common, right? Well, the truth is, they're all powered by the exact same single universal principle. Just one core idea in physics explains it all.
All right, let's dive in. The answer to all those questions is something called the electromagnetic spectrum. Now, don't let the name scare you. Just think of it like a huge family of different waves, a whole cascade of energy flowing through the universe. And the amazing part is, we figured out how to harness it. So, what exactly is an electromagnetic wave, or an EM wave for short? Well, it all starts with a tiny little thing called an electric charge. If you make that charge wiggle, really accelerate it back and forth, it creates these ripples of electric and magnetic energy that shoot outwards. What's incredible is that these waves are totally self-sufficient. They don't need air or water to travel through. They can just zoom through the empty vacuum of space at the fastest speed possible, the speed of light. This amazing power wasn't something we just stumbled upon. It actually started as pure theory. Way back in 1864, a guy named James Clerk Maxwell predicted these waves existed just using math, on paper. Then, more than 20 years later, in 1887, Heinrich Hertz actually managed to create and detect them in his lab. He proved Maxwell was right, and in that moment, when theory became reality, it basically changed everything for modern technology.
So, the recipe for making one of these waves is actually pretty simple. You just take an electric charge, and you shake it. That vibration creates these interconnected, almost dancing electric and magnetic fields that spread out, carrying energy with them. It's really that straightforward. You could say it's the universe's most basic way of sending a message.
Okay, to really get why these EM waves are so special, let's compare them to something we all know, sound. Sound waves are basically compression waves, kind of like squishing and stretching a spring. And they absolutely need something to travel through, like air. That's why in space, nobody can hear you scream. There's no air. But EM waves, they're totally different. They're transverse waves, more like ripples on a pond. And they don't need anything to travel through. They just zip right through the vacuum of space at a mind-blowing 300,000 kilometers per second. All right, so now that we've got a handle on what these waves are, let's take a tour and see how they actually build our world. We're going to start at the low-energy end of the spectrum with the invisible forces that power our communication and all those modern conveniences. First up, we've got radio waves. These are the real giants of the spectrum with the longest wavelengths of all. Because they're so long, they can travel huge distances without fading away, which makes them absolutely perfect for broadcasting. So yeah, every single time you tune into the radio, watch broadcast TV, or make a cell phone call, you're tapping into the power of these invisible giants. Okay, moving a little further up the spectrum, we get to microwaves. Their waves are shorter than radio waves, which means they can pack in more information. That's why they're perfect for things like radar, tracking weather systems, and of course, our beloved Wi-Fi. And, as we all know, they are also amazing at heating up last night's leftovers. So how does that kitchen magic actually work? Well, inside your microwave oven, there's a device called a magnetron that shoots out microwaves. These waves bounce all around the inside of the metal box and get absorbed by one specific thing in your food, water molecules.
The microwaves make these water molecules vibrate like crazy, and all that intense vibration creates friction, which in turn creates heat. And just like that, your food cooks from the inside out. No fire necessary.
Next up on our tour are infrared waves. You actually experience these every day as heat. Yep, any object that's warm is giving off infrared radiation. We've gotten pretty clever at using this. We've built thermal cameras that let us see heat, and night vision goggles work on this principle too. Oh, and that remote control for your TV, it's sending out its commands using little pulses of invisible infrared light.
Okay, now we're going to move up the spectrum. And as we go up, the waves get shorter, and the energy they carry gets a lot higher. This is where things get really powerful, but also where we start to see some real danger. Let's talk about ultraviolet rays, or UV rays, from the sun. These things have a real double-edged sword quality to them. On one hand, a little bit of sun is good for you. It helps your body produce vitamin D, which is essential. But on the other hand, these waves have enough energy to actually damage the DNA inside your skin cells. Too much exposure and you get a nasty sunburn. And worse, you seriously increase your risk for skin cancer. It's a classic case of the dose making the poison. Cranking the energy up even higher, we get to the famous X-rays. Their main superpower is their ability to penetrate things. These waves can sail right through soft stuff, like our skin and muscles, but they get stopped in their tracks by denser materials, like our bones.
And that right there is the whole secret to how we can see our own skeleton. When a doctor takes an X-ray, they're shooting these waves at you. The ones that go through your soft tissues hit a detector plate on the other side, making those parts of the image look dark or gray. But wherever the waves are blocked by your dense bones, the plate stays untouched, leaving those areas bright white. And voila, you have a picture of your bones.
Finally, at the very, very top of the spectrum, we have gamma rays. These are the heavyweights, the most energetic, most powerful waves there are. They're born from intense nuclear reactions, the kind of stuff that happens inside stars or when an atom is radioactive. Now, that immense energy can be super destructive for sure, but we've also managed to harness it for good, using focused gamma ray beams to sterilize medical gear or, incredibly, to target and destroy cancer cells in radiation therapy. So this brings us to a really important dividing line in the spectrum. The waves on the lower energy side, like radio waves and microwaves, are called non-ionizing. Basically, they just don't have enough oomph to knock electrons off of atoms. But the high energy waves, we're talking UV, X-rays, and gamma rays, they are ionizing. They hit with so much force that they can literally knock electrons loose, which damages atoms and the molecules they make up. And that is the source of both their incredible power and their danger. You know, when you take a step back and look at the big picture, it's honestly breathtaking. Figuring out how to use this invisible spectrum didn't just give us a few cool new gadgets. It has completely, fundamentally remade the world we live in. Just think about it. The ability to talk to anyone, anywhere on the planet, that's radio waves. The power to look inside our own bodies, X-rays. Everyday things like Wi-Fi and life-saving treatments like cancer therapy using gamma rays, it all comes from this one family of waves. We've even aimed our instruments at the stars, using radio astronomy to unlock the secrets of the universe. All of this exists for one reason. We learned how to see and how to use the invisible. And the most incredible part of this whole story, everything we've talked about, every single one of these world-changing technologies, it all comes from understanding and using just one single fundamental principle of physics. It really makes you wonder, doesn't it? We have built our entire modern world on a family of vibrations that are completely invisible to us. So, the final question is, what else is out there? What other unseen forces are just waiting right now for the next great mind to discover them and, well, change the world all over again?